Okay, thank you for coming to our presentation on S-Conductors. My name is Michael McDonald, and I'm joined by Jin Shen Chen, Stig DeCoster, Victoria Katsopoulos, Denise Montoya, and Kellogg Vincent Yao. Let's start with an overview of the situation. So S-Conductors is a manufacturer of semiconductors, which are high-tech computer chips used in pretty much everything that exists in the world today, from computers to laptop computers, cars, refrigerators, gaming consoles, lots of consumer products, as well as industrial applications. It's one of the most important things that we manufacture in this world. At the moment, the industry is extremely competitive. There are basically three large semiconductor manufacturers that take up the majority of the industry, as you can see in the picture on the right. The top two are TMSC, which is in Taiwan, and Samsung, which is in South Korea. The third largest is Intel, which is in the United States of America, which, as you can see, is a low percentage overall of semiconductor manufacturing. So the rest of the countries have smaller manufacturers in them. S-Conductors itself is a smaller manufacturer, which we assume hopes to increase its market share and grow over time. The problem with the industry, one of the problems in the industry, is the variable demand, which can vary uncontrollably and is difficult to sustain production to account for that, due to the very long lead time of 12 to 13 months in the case of S-Conductors. To combat this, the firm has come up with a risk mitigation strategy of multiple procurement options. And they've asked us to examine the problem of procurement and the risks as a whole. So we will now discuss what we consider to be the greatest risks for S-Conductors and the impact they have, the mitigation strategies we suggest for them to take to combat those risks, and then we will prioritize the risks and do a vulnerability analysis. Okay. So first off, we have Denise. Take it away.
Okay, so for loss to competitors, the first question is to identify and discuss the various risk factors that come into play with the global supply chain. So for the next slide, if you don't mind, Michael. So since S-Conductors has a 12 to 13 month lead time for manufacturing and demand is currently high at the moment, it produces a threat to their business as customers can shift their business to other global suppliers. So as of 2021, there's only 3 firms that are able to make the most advanced semiconductors, but there are many less popular companies that are also major suppliers of chips and other parts. The second question is evaluate the impact of identified risk on quality due to production changes. So if S-Conductors loses out on business to main competitors, their financial health will take a big hit and lost profits become a possibility in the future. So competition between manufacturers in the tech field also enhances uncertainty in both upstream and downstream markets, because manufacturers are forced to go over their supply chain strategies multiple times before finally transacting a response. Supplier competition has also been proven through observation to create higher transaction costs, as the same raw materials required for these semiconductors are also being sourced by multiple competitors. The drawback of competition is also supported by models that show a high potential for quality distortion from the supply side. Additionally, researchers who work on total quality management have shown that competition provides fewer opportunity to reduce variations in lead times and quality. Customer service at current levels can also run into burnout, which can result in unhappy clients and increased complaints. For the fourth question, state and explain an effective solution for S-Conductors to apply to mitigate supply chain risk. So for loss to competitors, given the extreme competition that S-Conductors works in, a large scale of capital investments is needed to keep up with demand and main competitors. So to mitigate the risk of losing out on business to competitors, S-Conductors should consider turning from a vertically integrated development to a model that leverages best-in-class strategic partnerships. Partnerships in microelectronics creates trust and security, but we should also keep in mind that it requires a deeper understanding of an overly complex global supply chain that includes things like design services, EDA, tools, intellectual property elements, etc. There's also the option to outsource some manufacturing to lesser known semiconductor makers, while S-Conductors continues to focus on designing the chips, including the technology in them. They can also continue to manufacture chips to a reasonable volume that works within their capacity. I will now pass it on to Jin Shen, who will talk about operational capacity and quality assurance.
Thank you very much, Dennis. So nowadays, there are very less firms have the capacity to produce chips operation at the S-Conductors. Next slide, please. At the S-Conductors cannot keep up with the demand and falling quality. These are the reasons to cause operational capacity and quality assurance risk. Because of the high-end technology, production skills are required and the increasing demand of the market. So this risk will cause pressure on the production team to produce higher volumes and the possibility of more defective components coming out of the production. Some quality assurance and quality control steps may be resulting in the faulty semiconductors because of must fulfill promise to the downstream customers. As conductor conduct a cost analysis on improving the production facility and create a chip that can be used in multiple products that will mitigate the risk of the operational capacity and quality assurance risk. So now Michael will give more details of the supply shortage, the demand variability risk. Thank you, Michael.
Thank you. Yes, I'll now talk about supply shortage and demand variability. So this risk is perhaps best highlighted with the recent example of COVID-19. So the pandemic forced people to stay home, which increased the demand for home computers as people relied on them more for work, school, socializing, and entertainment. In fact, worldwide demand for laptops increased 10.7% in the fourth quarter of 2019 in the fourth quarter of 2020. Furthermore, during the initial stages of the pandemic, demand for automobiles dropped drastically. Cars also contain thousands of chips, modern cars do. As such, the orders for chips for that purpose decreased dramatically. So chip manufacturers shifted production from chips made for cars to chips made for other consumer electronics to address the new demand. What happened, however, in late 2020 was that the car sales rebounded, and this caught the manufacturers by surprise. As such, due to the long lead times, they were unable to pivot production back to the auto sector, and this compounded the shortage. Now, as far as the impact, interestingly, because chips are in such high demand, the shortage of the chips did not hinder the profitability of the chip makers. In fact, during 2020 and 2021, most chip manufacturers had greatly increased revenue. The exceptions to those were two. One of them was from Samsung, and the other was Global Foundries. So with Samsung, due to a freak winter storm that struck Texas, one of their fabrication lines had to be shut down because it was in the vicinity. And due to the stop in production, their revenue dropped 2% for the first quarter of 2021. Global Foundries had a quarterly drop of 16% in that same time period. Their situation was different, however, as was due to a deal that they had made in 2019 to hand over one of their fabrication lines to a rival company, Vanguard International Semiconductor. This deal was made in order to give Global Foundries more capital so that they could further upgrade their other fabrication lines. However, due to the loss of their one line, they were unable to fulfill multiple orders, creating a backlog in production, and that resulted in the loss. These two examples highlight the need for semiconductor manufacturers to have continuous production. Essentially, the overhead cost is so high that they need to run 24/7 in order to recoup their investments. As such, the mitigation strategies that we recommend with respect to supply shortages and demand variability is to ensure, to the extent possible, continuous production for S-Conductors. This could mean multiple sourcing of their suppliers as far as raw materials or the tools that they use to make the chips, so that if one breaks down and they can't rely on one supplier, they can always shift to another without having to stop production, or at least to limit the stop in production. And that covers supply shortage and demand variability. Next, I will discuss a few images which are related. This first figure shows what happened due to the COVID pandemic. The pre-COVID-19 forecast of sales growth for the multiple applications of semiconductors versus the actual sales growth. And as you can see, wireless communication is the highest, and the actual sales growth was much higher than they predicted. In fact, all of the predictions were overtaken by the actual sales growth, except for, as I mentioned before, automobile manufacturing uses, which dropped significantly. The other being industrial, which would make sense as a lot of industrial applications were shut down due to the pandemic. Next image, as you can see, highlights the extremely long lead time in semiconductor production. In the case of S-Conductors, it's 12 to 13 months, but as you can see, if they want to expand their production, there would be a 12 to 18 month of just building the new factory, and another 6 to 18 months just to ramp up the factory, even before they can begin making the chips. The chip design itself could take up to 3 years. And then once that's done, the ramp up of production and this production cycle time would be 10 months or more. So that just highlights the incredibly long lead time necessary for semiconductors. Okay, next I will pass it off to Kellogg.
Thank you, Michael. So natural disaster is a risk as, can you please go to the next slide? Yeah, natural disaster is a risk as there are limited suppliers of goods in the industry around the world, and they are generally clustered together. For example, Taiwan and Japan in Asia Pacific region is a large supplier of semiconductors and the components that are needed to create them. Any disaster in the region can be devastating to the supply chain, as seen in the tsunami in 2011, which caused a 3-month delay in semiconductor production. Strategies to mitigate include stockpiling goods, having multiple plants around the world, and having the sufficient funds for these extra projects. Next slide. So figure 4 shows the Pacific Ring of Fire, and South Asia Pacific region is a large contributor to semiconductor production, and they are near the Pacific Ring of Fire, which has high seismic activity due to tectonic plate boundaries that can wreak havoc on production facilities and can cause devastating delays if they were to be destroyed or damaged by any natural disasters. Next slide. Figure 5 shows how interdependent the global supply chain is, as no one country or region has the capability to design and manufacture semiconductors end-to-end on their own. Any natural disaster or risk in any region will be a significant risk to the entire industry. And I'm now going to pass it on to Snigdha, and she's going to talk a little bit about equipment failure.
Thank you, Kavuk. Sorry. So another risk outline is equipment failure. This category is physical, which includes risk to building and facilities and equipment failure. So this critical equipment failure can disrupt business and can affect the supply chain upstream and downstreams, while at the same time affecting the bottom line. In a recent study conducted by a commercial property insurer, it was found that 94% of those surveyed considered equipment failure as a major concern, and 70% said that it was a top concern, while other 24% said it is a high concern area. The survey, which had respondents from Fortune 500 companies, said that it can take months to recover financially from losses due to equipment failure. So this is a quite high risk outline. And the risk impact for the equipment failure can lead to severe quality control issues. In an ideal world, equipment would operate 100% of time at 100% efficiency, which is very ideal case. And there is a vast difference when it comes to reality. There are various losses involved during manufacturing and transportation. So there are different forms of losses that can be grouped into downtime, speed losses, and defect losses. Defect losses can be linked to quality and can be defined when the equipment does not produce the product that meets the specified quality standard. This can lead to waste of time and money through scrape and rework. Now we goes to mitigation strategies. Here we talk about the high priority. Equipment failure comes in a high priority list. Organizations like S-Conductors should set a target to minimize defects through continuous improvement methodologies. If S-Conductor for some reason decides to make changes to their production process, it could mean doing equipment re-engineering and or equipment update. In this case, they will further need to make sure that they provide more operators and inspections training. They should also consider further inspections of the revised equipment to avoid or reduce defects as much as possible. Next slide, please. This goes to, I'll pass it to Victoria.
Okay, I'll be discussing our final major risk, which is geopolitical instability. Okay, so geopolitical risk can have a significant impact on supply chains with short to long-term consequences. Risks can range from regulatory changes, unfavorable trade agreements, or political corruption to regional instability or war. Political tension can take years to develop, and the resulting consequences can be devastating and long-lasting. You can go to the next slide. Yes, thank you. Political strife can arise from within the country, the region, or from international sources. The complexity and uncertainty of this risk makes it difficult to plan for, but its slower development means that the company will have more time to consider risk mitigation options. For example, the escalating trade war between the US and China saw the implementation of new tariffs and an increase in existing ones. S-Conductors should be aware that semiconductors are a key commodity in this trade war, as they are necessary tools for technological, economic, and political control. The United States recently added dozens of Chinese companies, including the country's top chip maker, SMIC, to a trade blacklist, which limited their access to licenses and cut their supply lines. S-Conductors could also be subject to similar restrictions from foreign governments in the future. China is also likely to respond by leveraging its economic influence through trade restrictions, talent recruitment, and cyber attacks. In the event of a war, S-Conductors could experience financial losses, loss of intellectual property, and the loss of physical property and employees. Regarding the risk impact, politics can result in a variety of interruptions, which can result in the inability to effectively guarantee quality levels are consistently met. Being blacklisted by a foreign government will cut them off from suppliers providing critical parts. They would not be able to produce goods at the necessary technological level needed to fulfill orders and to stay competitive. Increased tariffs and unfavorable trade agreements could mean that certain markets become inaccessible due to increased cost of business. To lower costs, cost-saving measures may be implemented to the detriment of the company. For others to gain access to intellectual property, rivals may conduct cyber attacks or use predatory recruitment tactics. The loss of knowledge can lead to less skilled and less experienced workforce, which can lead to more errors. There is a threat that production could be shut down or interrupted due to violence or delays. In extreme cases of a military engagement, materials could be destroyed, damaged, stolen, or misplaced during or after an attack. Furthermore, facilities may be damaged or destroyed entirely, and employees may be incapable of working or be killed. Mitigation strategies include several things. Geopolitical instability typically arises after a prolonged period. The culmination of the tension may be sudden, but the buildup can take years. By monitoring these changes, S-Conductors can establish plans to survive this shift or enter or exit the country if needed. S-Conductors can follow the lead of several other semiconductor and computer board manufacturers and expand beyond a single region. To lessen the impact of political instability, they may relocate their manufacturing centers to different manufacturing regions or build relationships with suppliers within different regions. They can also outsource functions to external businesses or enter partnership agreements with them. S-Conductors should look for countries with advantageous treaties or government incentives. They should evaluate foreign relations and assess the political climate prior to and during business with a foreign country. S-Conductors can see if they are eligible for any additional government subsidies and monitor government websites to discover any beneficial trade agreements in negotiations. If they are unable to move, expand, or diversify their supply base, they should build stronger communication networks and carefully monitor their situation by gathering information from reliable news sources. So I'm going to pass this on to Jin Shen now. Oh, no, I won't. This graphic shows the flow of goods between the relevant countries that I previously discussed. More information is in the report about China and the US and the importance of Taiwan for both of their political agendas. Now I will pass it on.
Thank you very much, Victoria. So according to the explanation of all the risks which our team has defined, now we will give the risk assessment. Next slide, please. So the highest priority will be the supply shortage and the demand variability. And the next will be equipment failure. And the operational capacity, quality assurance, and loss to the competitor will be the moderate priority. The low priority will be the geopolitical instability, and the lowest priority will be the natural disaster. Now I will pass to Carlo Vincent Yao. Thank you.
Thank you, Jin Shen. So I'm going to talk a little bit about our vulnerability analysis. Next slide, please. So this graph shows how we categorize the risks for our vulnerability analysis. So for supply shortage and demand variability, it has the highest priority and the highest likelihood of occurring. The vulnerability level for supply shortage and demand variability would be considered low, as there is little risk of targeted attacks for this risk. This risk would present as devastating on the impact of loss in the areas of supply chain systems, processes, and components. The inability to obtain needed components can halt processes and disrupt the supply chain. Excessive demand that cannot be met can lead to the loss of market share and financial losses. A failure to adjust to a sudden decrease in demand can lead to inventory buildup, also leading to significant financial losses. This risk can lead to the failure of the company if not properly managed. Equipment failure would have a high priority and a high likelihood of occurring. Vulnerability level for equipment failure would be considered low. There is little risk of targeted attacks for this risk. There's a very small chance that disgruntled internal employees may intentionally damage machinery. This risk would present as severe on the impact of loss in the areas of supply chain systems, processes, and components. Depending on which system has failed, there can be significant effects. If production areas are contaminated, it is possible that components and inventories may need to be discarded. If machinery fails completely, production can stop for days or weeks, which can result in tremendous financial losses. The investments needed to replace equipment are high and may take a long time to arrive and to be installed and calibrated correctly. Improperly functioning equipment can lead to reduced quality, and operations and staff may be reduced up to 50% while repairs and installations take place. Operational capacity has moderate priority and moderate likelihood of occurring. Vulnerability level for operational capacity would be considered low for this risk. There is little risk of targeted attacks for this risk. This risk would present as minor on the impact of loss in the areas of supply chain systems, processes, and components. It is possible that processes and components can be negatively affected by the facility operating over operational capacity. For example, without proper downtime to inspect, maintain, and repair machinery, damages can occur. Staff may become overly fatigued, leading to errors. In addition, rushing orders may disrupt established processes, and operations may be reduced for a few hours or up to a day. Loss to competitors has a moderate priority and a moderate likelihood of occurring. Vulnerability level for loss to competitors would be considered low for this risk. The likelihood of physical interference from competitors is low, and the facilities and in-transit products are likely not at risk of damage or destruction by competitors. The risk would present as noticeable on the impact of loss in the areas of supply chain, systems, processes, and components. The industry itself is difficult to enter due to high startup costs. Therefore, there are few competitors in the market. There's a possibility that competitors could lure away employees through targeted recruitment activities. They could obtain better agreements with shared suppliers, reducing access to components. If they succeed in obtaining valuable contracts with customers and take more orders than S-Conductors, then it is possible that S-Conductors could find themselves with a significantly reduced output. In this case, it is possible that the financial losses could force S-Conductors to close manufacturing facilities, reduce staff, and reduce operations. The facility or organizations can experience a visitor staff reduction of up to 25% if output is temporarily reduced. Geopolitical instability has low priority and low likelihood. Vulnerability level for geopolitical instability would be considered high for this risk. S-Conductors produce semiconductors which are considered both valuable and critical to the future economic growth of countries and regions which produce these products. There is considerable political value placed on these goods as technological competitiveness is strongly linked to emerging technologies which use these components. Intellectual property is at risk of cyber attacks as few companies have the ability to produce goods of the highest quality. In case of war or attack, the facilities may be attractive targets. This risk would present as severe on the impact of loss in the areas of supply chain systems, processes, and components. As mentioned throughout this report, semiconductor producers have been targeted by foreign governments in the form of blacklisting and through the implementation of new and increased tariffs. In the event of war, supply lines can be cut, facilities damaged, and components stolen or damaged. The high value of the goods and machinery may prevent the total destruction of facilities, and inventory should be moved elsewhere prior to attack if possible. Natural disaster has the lowest priority and lowest likelihood of occurring. Vulnerability level for a natural disaster would be considered low as S-Conductors manufacturing facility is not presented as a possible target for severe levels of deterrence. However, this risk would present as devastating on the impact of loss in the areas of supply chain systems, processes, and components. Most items at S-Conductors would be destroyed or damaged beyond repair. The manufacturing processes, components used for manufacturing, and supply chain activity to distribute products globally would come to a halt as the organization may be reduced by up to 75%.
Okay, and that concludes our presentation. Thank you for watching.